Hi everyone, welcome to the lecture series of Logic Gate. In this session, we will look into what is a logic gates, different types of logic gates, and finally, we will conclude with what are universal gates, which gates are called as universal gates, and why. Let's start our session. Logic gates are the circuit made up of transistor diodes and resistors, and it processes one or more input signals in a logical fashion. After performing the operation, it produces the output as 0 on 1 based on the input and the logic gate on which it is working. The first logic gate we will be looking into an AND gate. AND gate will produce an output of 1 if all the inputs are 1, otherwise it will produce an output as 0. This is the truth table of the AND gate, and this is the logic symbol. We see there are two inputs in this and one output as y, and the expression becomes y is equal to a dot b dot, indicating the AND operation. Next gate we are looking into is the OR gate. So OR gate is, again, it is having the capacity of taking two or more input and produces one output. It will produce the output as 1 even if one of its input is 1, then the output will be 1. If it is all inputs are 0, it will produce the output as 0. And this is the logic symbol of OR gate. In this example, again, we are having two inputs A and B and one output as Y, and the expression is A plus, indicating the OR operation, A or B. If any one is 1, then the output is 1, that is A plus B is equal to Y. The next gate we are looking into a NOT gate. It is also called as inverter. So it is having only one input and one output. Its speciality is whatever the input it is taking, it will produce the opposite of that as the output. That is, if you are passing a 0, output will be 1. If you are passing 1, the output will be 0. And this is the logic symbol of NOT gate, a triangle symbol and a bubble in front of that, indicating it is a NOT gate, and the expression becomes y is equal to a bar or a. Next gate we are looking at as NAND gate. So again, NAND gate has two or more input, but it will produce only one output signal. The output is 0 if all the input is 1. Remember this, NAND gate is made up of two gates, and NOT. So in AND gate, if all the inputs were 1, then the output used to be 1. This is opposite of that, that is, if all the inputs are 1, the output will be 0. And this is the logic symbol. If you see this, this was the AND gate, and NOT gate is indicated with this particular bubble. And for AND gate, the expression was y is equal to AB, and for NAND gate, it has become AB whole bar. So it is negated, not AND gate. Similarly, we are looking into the NOR gate. NOR gate is combination of, again, two gates, OR gate followed by a NOT gate. In OR gate, in NOR gate, all input must be 0 to get the output as 1. And we used to get output as 0 if all the inputs has 0 in case of OR gate. And this is the logic symbol, this is the OR gate, and this is the NOT gate. Bubble indicates the NOT gate, and the expression for OR gate was A plus B, whereas for NOR gate is A plus B whole complement. And also NAND gate and NOR gate are called as universal gate. The reason for that and detailed explanation will continue at the end of this presentation. Next gate is the XOR gate. If there are even number of inputs of 1, the XOR gates are present, the output will be 0. So here we see 0 0 again. 1 it is 0 number of times, so the output is 0. 0 and 1 odd number of ones, so the output is 1. 1 0 again odd number of ones, the output is 1. 1 and 1 it produces the output as 0, and this is the logic symbol of XOR gate, and A plus written inside the circle plus B, this is how an XOR is represented, and Y is the output. The next gate is XNOR gate. Again it is XOR gate followed by NOT gate. So whatever was the output for the XOR gate, so with XNOR will be the complement of this. So for this we were getting 0 1 1 0, here we will get 1 0 0 1. So the logic symbol also, this is an XOR gate, and a NOT symbol is added in front of this, so that becomes XNOR gate, and the expression also A XOR B whole complement will be the XNOR gate. Next gate is the buffer gate. So buffer gate is whatever the input is, it produces the same output. If it is 0 it is 0, if it is 1 it is 1. What exactly the use of this particular gate is, in a circuit, if it is going through multiple number of gates, there are chances that the input value may increase or decrease. So this gate, it does the power amplification. For example, we need the output as 1, instead of 1 we will be getting 0.9, which will be amplified to 1. That is what is the use of the buffer gate, and the expression is A is equal to Y. So those were all the logic gates, but two gates, NAND gate and NOR gate, are called as universal gate because we can construct any of the basic gate using these gates. So these two gates are called as universal gates. To prove it as a universal gate, so this we have already looked. This is the NOT gate, this is an AND gate, and this is the OR gate, and these are the expression which we have already studied. Now NAND gate, only using NAND gate, if I want to construct NOT gate, what I'll do is, generally NAND gate takes two inputs A and B, but I'll pass only one input and it will produce me the output as A bar. And if I connect two NAND gate continuously, I'll get the same operation as of a AND gate. If I connect NAND gate to two NAND gates but giving only one input, just now we saw that if we connect two inputs, pass only one input, we get A bar. Similarly we are getting A bar and B bar. A bar and B bar again connected to a NAND gate, we will get the output as A plus B, which is nothing but the OR gate. Similarly, using NOR gate we can construct all the basic gates. So this is how the NOR gate for NOT gate. For AND gate, if you look, two NOR gates are given as input. If you see the NAND gate, two were connected continuously, whereas in NOR gate, two are separate inputs are given as A and B. This A bar and B bar, again it is passed to the third NOR gate to produce the output as AB. And in case of OR gate, if it was NAND gate, it was connected like this, but for NOR gate it is connected continuously to produce the output as A and B. Since these basic gates can be constructed using only NAND gate and NOR gate, NAND gate and NOR gate are called as universal gate. Thanks for watching the video.